Photovoltaic solar energy is a renewable and clean energy source that uses solar radiation captured by solar panels to produce electricity. This energy is stored in a battery bank and then taken through a power inverter and thus obtain a voltage similar to what is supplied by the home's electrical grid. I am going to briefly describe each component of this photovoltaic energy system and later how to make a consumption calculation. The process begins when sunlight falls on one of the faces of a photoelectric cell, which makes up solar panels. This produces an electrical potential differential between both faces, causing the electrons to jump from one place to another, thus generating electric current that is then transported and stored for later use. Two or more solar panels can be connected in parallel if it is required to maintain the same voltage level and a high current. Or they can be connected in series if it is required to obtain a greater potential or voltage differential while maintaining the current intensity constant. The charge controller or regulator. They are devices that fulfill the objective of monitoring and protecting against deep charges or discharges of the battery bank or accumulator within a solar installation. These devices can be 12, 24, or more volts. Said charge controller is installed between the solar panels and the battery. Therefore, it is essential to choose the optimal controller according to the needs of your solar installation. There are two types of charge controllers on the market. PWM controller, which is used when the voltage between the solar panel and the battery is exactly the same, and the MPPT controller, which is characterized by including a maximum power point controller. That is, it does not matter if the solar panels supply higher or lower voltage than the battery's support, this controller will adjust the voltage and current levels to an appropriate level. The battery bank. They are responsible for storing the energy generated in the solar panels during the hours that solar radiation affects and then using it at night, on cloudy days, or when the energy demand is greater than that produced by the solar panels. There are several types of batteries, such as open lead-acid batteries. They contain 6 separate but series-connected compartments that are immersed in sulfuric acid. The plates that make up the battery contain positively and negatively polarized electrodes that alternate within the battery. This type of battery is normally found in cars. Downloading is only allowed up to 30%. AGM batteries. They are an excellent option for small and medium-sized photovoltaic installations as it is a demanding type of battery with a long useful life and high efficiency. Due to their nature, they do not require special maintenance or periodic review of their internal acid levels. Lithium batteries. Lithium batteries charge faster than other types, offer more energy density, and have a longer lifespan. They do not have a memory effect, so they could be discharged at 100% or half without the battery suffering. It does not require maintenance nor emits gases, so it can be installed in a place without ventilation. The power inverter. It is an electronic device that performs the function of changing the input voltage of direct current to an output voltage of alternating current. That is, it transforms the 12 volts or 24 volts of direct current from a battery to 220 volts into alternating current, like the one we have in the outlets in a home. There are 3 main types of investors. PWM or square wave inverters. Its output signal is a square wave, which is not that efficient. They are cheaper, but they produce harmonics that generate interference such as noise and circuit heating. They are not suitable for induction motors or any inductive load. They are generally used to power a television, a computer, or low-power non-inductive loads. SPWM or modified wave inverters. They are more sophisticated and expensive than the previous one since they use electronic switching to modify the width of the pulse, thus obtaining a modified wave as close as possible to a sine wave. The output is not yet a true pure sine wave, but it is close. The harmonic content is lower than in the square wave. They are the inverters that have a better quality-price ratio and can be used for lighting, computers, televisions, or frequency converters for electric motors. Pure sine wave inverter. These devices have state-of-the-art microprocessors that allow them to generate a sine wave similar to those supplied by the electrical network in our homes. It is advisable to use this equipment in inductive loads such as electric motors and appliances or loads that require a pure sine waveform, such as refrigerators, among others. The disadvantage it has is its size and mainly the difference in cost, which is greater than less sophisticated inverters, but in exchange its efficiency is much greater. So here we have the entire photovoltaic system, where the solar energy is captured by the solar panel, then that energy is stored in the battery to later be used by the power inverter and thus supply electrical energy to different equipment and appliances. Now, I am going to do a calculation to determine the power and number of solar panels if we have two batteries. For the battery bank, lead-acid batteries, AGM or lithium batteries can be used. I'm going to assume the case that for this we already have two batteries available. These batteries are 12 volts and 100 amp hours. We have the possibility of connecting it in series or in parallel. But the most advisable thing is to connect the batteries in such a way that we obtain the highest possible voltage, since this will help us obtain a more efficient result when using the power inverter. If the connection is in series, then the voltage is added, thus obtaining 24 volts. With this, what we want to find is the total energy that the batteries can supply. So, the total energy of the batteries is 24 volts multiplied by 100 amp hours, thus resulting in a total energy of 2,400 watt-hour. Be careful, do not confuse power with energy. Power is the multiplication of voltage and current in amperes, and its unit is watts, while energy is power multiplied by time, and its most used unit is the watt-hour. Let us remember that a battery cannot be discharged 100% since its useful life would be considerably reduced. That is why the energy available for our use will only be 50% of the total energy. So, the available energy will be 50%, which is the same as 0.5 multiplied by the total energy, which is 2,400 watt-hour, thus obtaining 1,200 watt-hour of available energy. Now, let's see how to do the calculation of solar panels. To do this, we must take into account the power of the solar panels at what peak and the solar radiation in the area where the installation of the solar panels is going to be carried out. This value is measured in peak sun hours. For the power of solar panels, there are several values that you can choose from. For this case, the most recommended is 400 watt picopanels. The peak sun hours of the sun range from a value of 0 when there is no solar radiation and up to 5, which is the maximum value when there is a lot of radiation. This value will depend on the area where we are located. For this case, we are going to consider 3 peak sun hours. You can look up this value on the internet depending on where you live. Then, the daily energy available will be the 400 watt peak of the solar panel multiplied by the 3 peak sun hours, which gives us a value of 1,200 watt-hour that each solar panel will provide us per day. With this value, we can now find the number of solar panels that we will need. The number of panels is equal to the total energy needed, that is, that of the batteries, which was 2,400 watt-hour, divided by the daily energy available from each solar panel, which was 1,200 watt-hour, thus giving us a result of 2. Therefore, it will require 2 solar panels of 400 watt peak at 12 volts. These panels must be connected in series to obtain the 24 volts necessary to charge the batteries. Regarding the charge controller, it has to be 24 volts and with a current between 20 to 30 amps. The current inverter has to be greater than the sum of the powers of the solar panels. In this case, the total power of the solar panels is 800 watt, so the inverter would have to be 24V with a power of at least 1000 watt. The type of wave signal will depend on the use given to it. In this case, it will be considered a pure sine wave. In conclusion, for two batteries of 12 volts and 100 amp hours, two solar panels of 400 watt each will be required. A 24-volt, 20-amp or more charge controller, a 24-volt inverter with a power of 1000 watt or more. As for the connection of this entire system, it is explained below. On the charge controller, there are terminals where they indicate the connection for the solar panels, the battery bank, and the output for the inverter. From the positive terminal that indicates for the solar panel, a cable is run to the positive terminal of the solar panel. Then from the other negative terminal, it is connected to the positive terminal of the next solar panel in order to obtain the series connection that gives us 24 volts. Finally, from the last remaining negative terminal, the cable is connected and brought to the negative terminal indicated by the controller. Now, from the positive output for the battery, it is connected and taken to one of the positive terminals of one of the batteries. From the negative terminal, it is connected to the positive terminal of the other battery to obtain 24 volts in series. From the remaining negative terminal, it is taken and connected to the negative of the controller. Finally, from the two remaining terminals, they are connected and taken to the power inverter to convert a voltage of 24 volts in direct current to a voltage of 220 volts in alternating current, which is the same as that found in the electrical outlets. The house. Well, friends, this would be all. If you liked the information, don't forget to like and share this video. See you later.